So first of all, welcome. Thanks for coming to this session in which we will discuss serverless Java. Before we do so, some logistics. So my name is David Delabassee. I work at Oracle in the serverless team. Despite my accent, I'm not French. I live in Belgium, but on the French-speaking side, and hence my funky French accent. So this was me some time ago in a conference in Sweden. And someone in the audience tweeted that it's not a real conference unless you read Oracle's safe harbor statement at least once. So here it is. Finally, I'm using one of those MacBook Pro with the new keyboard. And anybody is using that kind of MacBook with the new keyboards? No? Well, if you were using that keyboard, I think you would agree with me that there's a real problem with that. With that keyboard. So today I'm going to do demos. If any of my demo fails, it's not because of me, it's because of that broken keyboard. No, but really. So, first, I will quickly give you an introduction on serverless to make sure that we're on the same page, and then we'll look at the role of Java within the serverless space. So the first thing that we have to clarify is serverless. So whenever I say serverless, I really mean function as a services, FaaS. So what is FaaS? So first, we have this notion of a function being a small piece of code that will get something in input that will basically trigger the function execution. And then the function will most of the time produce some output. So it's not a function as we have in mathematics in the sense that the function can also have some side effects. But the key aspect of a function is that it's a well-bounded piece of code that will perform just one task, right? So that means that functions are quite ephemeral in the sense that they will be invoked, they will perform their task, and then they will die. And new developers will basically spend your time writing function. We then have this as a services piece, which is basically the compute element on which your function will run on. So basically, FaaS, serverless functions, give us the ability to write and run code without having to worry about the underlying platform. Why? Because we can clearly distinguish two roles within the FaaS space. We have function developers, you, and we have FaaS platform providers. And the FaaS platform providers' responsibility is basically to make sure that everything runs. So that's about provisioning the platform, scaling the platform, maintaining the platform, securing the platform, and so on and so on. So that's what we're going to discuss today. If you are looking at the market, there are sometimes discussion about serverless versus containers. At the end of the day, it doesn't matter because you will see that today, basically, the project that we're using, FN project, is using under the hood containers. But if you look at all the FaaS platform solutions, basically, they are all using containers. Some, like FN, are using containers explicitly, so containers can be exposed. Some other solutions are using a container implicitly. So you don't necessarily see that containers are being used, but clearly containers are being used. Now, we clearly see that there is a strong momentum around the FaaS space within the market. So the question that we should ask ourselves, what about serverless Java? First, we have Java, which is a very popular programming language. Depending on where you look at, Java is either first or second. Nevertheless, it doesn't really matter. At the end of the day, I think that we can all agree that Java is a widely used programming language, right? Now, if we look at Java within the serverless space, we don't have a lot of metrics, but the few metrics that we have aren't very good. So this was a survey that was conducted by the Serverless Frameworks. And basically, the Serverless Frameworks is a solution that allows you to write on top of FaaS platform serverless function using different language. So it's basically an abstraction of different FaaS platform providers. So the Serverless Frameworks guys asked, okay, what programming language are you using today to write serverless function? And well, you see that we have this big green arc, which is Node 6. So JavaScript basically 70%. Then we have Node 4, that purple box, a little bit over 5%. So basically at the end of the day, over 75% of the Serverless Frameworks user are writing function using JavaScript. We then have Python, let's see, Python 3.6 and Python 2.7. If you add those two, 50%. And Java, it's basically this small yellow box at the top, which is not even 5%, and it's Java 8. So less than 5% of the serverless frameworks developers are using Java to write serverless function. That's one metric that we have. Another metric that we have is the subsequent question, where basically, so the first question was, what are you using today to write serverless function? And this question is, what do you plan to use to write function in the future? And first, node 6 is not even on that chart. It would be way above. But if you look at Java, it's basically the middle orange line, and it's most of the time it's below 5%. Anyway, let's say that over time, it's just stay at 5%. So clearly, the usage doesn't seem to increase. The usage of Java within the serverless space, at least using the serverless frameworks, is not increasing if we look at that statistics. So how can we explain that? How can we explain that? On one side, we have Java, a very popular programming language, and on the other hand, we have this new emerging space, the function as a service space, where clearly Java is not widely used. So the first thing that we might want to look at is the historical serverless fast landscape. So it's a pretty new landscape. But if we look at the three historical fast platform providers, that is Amazon, Microsoft, and Google. So for Amazon, it's OK. I mean, they are supporting Java 8 since 2015, so that's good. Azure only supports Java since February of this year. So that might explain why Java is not popular yet in that space. And Google Cloud Function, it's worse. They are only supporting Java since last month. It's Java 8, and it's alpha support. So it's not even supported in production. So clearly, that landscape might explain why Java is not very popular within that space at this stage. Something else is that if we look at the fast space, this is a pretty new space. And clearly, we see a trend where basically startups are using whatever technology they feel comfortable to start to write their stuff. And it's only when they need to basically mature that they're switching to Java. So we might expect that some of the development that are done today using, let's say, Node or something else within the serverless space might over time switch to Java whenever that needs to scale, whenever that needs to be more secure, and so on. So that is just a guess. We don't have any metrics to prove that, but it's a trend that we're observing within other space. Now, something else that might explain why Java is not popular in that space is maybe Java is not a good fit for writing serverless function. It might be as simple as that. So if we look at the beginning of fast function, functions were basically used to write glue code between multiple services. Maybe Java is not a good fit for writing such a glue code. Functions are ephemeral. So function will be invoked, the function will perform its task, it will last for 100 milliseconds, 200 milliseconds, maybe 500 milliseconds, and then it will die. We know that Java has been tuned for many years to optimize long-running application. So again, maybe Java is not a good fit for such a short-lived application. So when we started to work on our fast offering at Oracle, we wanted to make sure that Java could be used within the serverless space. So we basically set ourselves some kind of blueprints that we want to achieve when it comes to writing serverless function with Java. And I will go over all those blueprints as we go. So to illustrate that, I'm going to use FN Project, which is an open source fast platform. So Oracle has announced Oracle Function, which is a managed fast offering. And under the hood, Oracle Function is using FN. So today, I will just use the open source side. So it's I'm just using FN. So it's an open source container native fast platform. It's Apache v2. Everything is on GitHub. So it's not open core where we just have a subset on GitHub. Everything is on GitHub. So you can take it. And one of the benefits of an open source fast platform is it's basically a platform independent. So you can run it on Oracle Cloud. That's basically Oracle Function. But you can also take FN and run it on different cloud. It could be Amazon, it can be Microsoft, and so on. It doesn't matter. At the end of the day, everything is open source. Now, the thing is that if you are doing that, you just have to keep in mind that basically, if you are running the fast platform, you will have to deal with the two roles, the two responsibilities. So you will be the fast platform developer, but you will also have to manage the platform. So you will also be the fast platform provider. If you understand that, there's no issue with that. And last but not least, you can also use FN on your laptop. That's what I'm doing here. It's very convenient for example, development. So it's not a subset of the platform. It's basically the whole platform that is running on my machine. So FN is container native. So you will see through my presentation that basically in FN, everything is a container. So you give to FN a piece of code that is your function, and FN will turn that into a container. Now, you don't need to understand nor provide any Docker file, so you don't need to understand all the details of Docker. Everything is handled for you by the platform. So let's have a look at the demo. So the only thing that you need to have running on your machine to use FN is Docker. So I have Docker running on my machine, it's empty. So the first thing that I'm going to do, I'm going to start FN. So I will start FN in detached mode, and there we go. If we look, we have one container, and that's basically one instance of FN running locally on my machine. So the next thing that we want to do is basically bootstrap a function. So FN init. So FN is the CLI, so the FN command line tool. It's basically your interface to FN. You can use it to bootstrap function, to control FN, to deploy function, and so on and so on. So let's bootstrap a function. Given the context, we're going to use the Java runtime, and we need to give our function a name. So my function will be called Duke. So if we look at the Duke directory that has been created, we have a bunch of files. We can see that we have two Java classes, given that we're using Java. So hello function is basically a simple hello world serverless function that you can extend. We also have this hello function test, which is basically a class, a JUnit test-based class that we can use to test our function. You can also notice here two files. A func.yaml. So a func.yaml is basically a file that contains some metadata about the function. So for example, the name of the function, the version of the function, and so on and so on. And then we also have a pom.xml. So basically in FN, a serverless Java function is simply a Maven project. So that means that, for example, we can do this. We can use Maven to test our function. That's the keyboard. Oops, and that was me. So my function is being tested with Maven, and obviously I haven't changed anything, so everything works. Not only that, well, let's first have a look at the function. So what I'm going to do here, I will deploy the function. I will deploy the function locally. To deploy a function, I need basically to deploy a function within an app, an application. An application is simply a way of grouping together a related function. So it's simply a namespace. So let's create an app. If I look now at the apps that I have a bunch of apps, and I have these New York apps in the middle. So now I can deploy a function to that app. So fn deploy, and I see so I want to deploy my function to this application. Either I specify which function I want to deploy, or in this case, the CLI will just pick up the local func.yaml. Let's see. We're going to use the -verbose mode to see what's going on behind the scenes, and I'm going to add a local flag to see what's going on. Oh, sorry, to save some time. So if we look what happened behind the scenes, basically the FN CLI is turning our Java function into a Docker image. So we can see that, for example, we are using Maven here to build a function, and then the result is being put. So it's a multi-stage build. The result of so that jar, basically the jar of our function, is being put in a specific Docker image that will run our function. So now if we look at if we list the function within the NIC apps, we do have one function that we can invoke. It's a pretty basic function, so NIC, and the function is called Duke. And it's basically a simple hello world. And I have the ability to pass it to pipe it some payload. Let's see, -n. I can also inspect my function. So if I inspect, I said, fn NIC, and the function is Duke. And I have here an HTTP invocation endpoint that I can use to invoke my function through HTTP. I have the ability to add additional HTTP endpoints through the use of triggers. So what I'm doing here, I'm just running the function locally. Obviously, at the end of the day, you want to run the function within the cloud. For doing that, You just need to switch context. So I'm using a local context here, and here I'm going to switch to an Oracle Cloud context. Fn use context OCI. Now I'm using an Oracle Cloud context, so in a data center, I think in Phoenix. And if I look at the apps that I have there, I don't have the New York's app, so I need to create. Sorry, I need to create this app, and now I can deploy again this function. And I'm going to remove the minus local. Basically, minus local means whenever the function image is built, don't push it to a registry. Given that I'm remote here, I need to push obviously my image. And you see that basically it takes a little bit more time because we have to go through the network. And now if I inspect the function again, I should have a different. You see that basically I have now an endpoint that I can use, a remote endpoint that I can use to connect to my function. So I'm going just to save some time, I'm going to switch to the local context. So context local. Now let's see. What we can do next, we can have a look at the code. So given that it's a Maven project, we can use any existing tool that support Maven, like IntelliJ, Eclipse, NetBeans, and so on. So if we look at the source, we have the test of the function. And we have the function itself. Something to notice here is that, so it's our basic hello world function that I likely extend because nobody's in the business of writing a hello world serverless function. You see the function, basically it's a simple class with at least one method. That's our serverless function. In this case, the serverless function gets in input a string and it produces a string in output. This is pretty basic. What we can do is the following. So we create a new type. So an event type, an event has a name. Let's see, an event has a date. We need a constructor, and we need default constructor, and we need getter and setter. So what I've done here, I've simply created a new Java type, an event type. It's pretty basic, right? So what I'm doing next, we're going to use the input as the name, and we're going to use the local date now as the type. As the date. And we're going to return that object. It doesn't work. Why? Because I need to update the signature of the function. So now we get a string in input, and we are outputting an event type in output. So let's deploy that guy. So I'm using the local context. So given that I've changed the code, obviously the function is being rebuilt. And it doesn't work. Anybody has a guess why it doesn't work? Sorry? Yeah. We can see what's going on if we add -v. And we'll see that each time we build a function, we are testing the function. So the test indeed failed. So we need to fix the test. And it should not, yes, it works. Don't fix the test by removing them. That's only something that you can do when you're on stage in front of an audience and you're streaming on the internet. But don't do that at home, please. There is a server running locally in Docker on my machine in this case. No, the server itself is FN, and FN is technically written in Go. Sorry? Yes. So let's see. So we have deployed the function. Now we can invoke that function again. So fn invoke, the application was NIC, and we will pass it some payload. NIC, no, it's code NIC, I guess. fn invoke and see jux. And well, let's GQ that. And this is the output of my function. So basically, my function on the Java side is simply outputting a Java object, so this new event type. But you see that the Java object was automatically converted by the platform to JSON. So what we should see here is that there's no interface, there's no annotation, there's nothing specific to FN. So it's really plain old Java code. So if we go back to the slide. So we had a quick glimpse of how to develop serverless function using Java in FN. For that, we're using what we call an FDK, a function development kit. I was using the Java one. Well, sorry, I was using the Java FDK. So the Java FDK provides us, for example, support for JUnit, support for Maven, input and output coercion. So that's the ability to get JSON payload to the function. It's automatically converted into a Java type. And if my function is outputting any Java type, it will be automatically converted to a JSON payload, and so on and so on. So basically, the function development kits help us to easily write a function using Java. Now, if you don't want to use the FDK, you can still write a function using Java on FN, but clearly, it would be a bummer to have that approach. The FDK really helps us to write functions. So if we go back to our, basically the basic requirement that we gave ourselves when we started, plain old Java, yes, you saw that I was using a plain old Java code, basically to write serverless function. Ability to use established toolchain, I've used Maven, I've used IntelliJ, so we're good on that front. Now, let's talk quickly about the ability to build complex application. And for that, there's something in FN which is called FN flow. I told you at the beginning that functions are short-lived. So basically, a function will be invoked, it will live for 100, maybe 500 milliseconds, and then it will die. That basically means that you shouldn't hold the state, any kind of state within the function. It's just too expensive. If your, let's say, 200 milliseconds function needs to connect to a database to hold some kind of states, well, just establishing the connection to the database will be more than those 200 milliseconds. So forget about that. Having said that, there is a specific use case where it makes sense to hold the state within a function. And that is when you want to compose together multiple functions. So the idea is the following. You have, let's say, a main function that will invoke another function. We are going through the network, obviously. This is an asynchronous invocation, so it will take some time. Once we have the result from that invocation, the main function will invoke another function. That other invocation might fail because we are going through the network. So we are waiting for the result or the error of that second invocation. And basically, we're defining a pipeline of function invocation. For doing that, we have FN flow. FN flow is highly inspired from the completion stage API that we have in Delabassee. It's basically the exact same API, except that the completion stage API of Delabassee allows you to define a pipeline of asynchronous task execution that are executed within the same process, within the same JVM. Here, we are talking with FN flow about a pipeline execution of serverless function. And obviously, given that we're going through the network, this doesn't happen within the same process. But from an API standpoint, if you know the completion stage API, you will be very familiar with the flow API of FN. This is how it looks like. So first, we need to have a flow object. So a flow object will basically contain the result of a function invocation. So we are creating this object, and then we are creating the pipeline execution. So that's the second line. So you see the first line is an invoke function method. So basically, we're invoking a remote function. And you see this is the afunc is basically the ID of my remote function. This doesn't have to be a Java function. It can be a function written in Go, written in Python. It doesn't matter. What we are doing, we are using Java to do the orchestration. So this is asynchronous. Once we have the result, we are using the then apply to do something with the result. And that second line, we are just defining the pipeline execution. Nothing happened there. It's on the last line where basically we do a get that we're triggering the function execution. So to illustrate that, I have this simple trip booking application where the idea is basically to book a trip. So whenever we book a trip, we want to book a flight, we want to book an hotel, and we want to book a car. And finally, we also want to send an email to the user with all those details. So for that, we're going to use multiple backend functions, one written in Java, one written in Ruby, one written in Node, and the email one is written using Python. And what we're going to look what we're going to do, we're going to use the FNflow API, so that's the trip booking function, to basically orchestrate those multiple functions together. So let's have a look here. So let's I have an application, yes. I have the travel application that is deployed on my machine. And if we look at the function that we have within this application, we have a car booking function, we have a car cancel function, we have an email function, we have a flight booking function, and so on and so on. I'm going to invoke the one at the bottom, so the trip one that is using FNflow to do the orchestration. Before I do so, I need to do a bit of setup. So I'm going to start. So I'm starting 3 containers. Now, there's just one container that is really needed, and that is this FN project flow. That's basically an adjacent process that will deal with state management whenever we are doing serverless orchestration. Those 2 containers, Flow UI and Bristle, are just used for the demo so that we can see what happened behind the scenes. Now again, here I'm taking the fast platform provider hat. So that's why I need to start my Flow server. But obviously, if you're going to use FN in a cloud provider, that should be handled for you. So everything is started, and I will just make sure that my functions are correctly configured. So to invoke the trip function, I have this simple payload that I just need to pass to my function. So invoke. So this was the travel application, and in the travel application, we're going to invoke the trip function. And that's where my additional containers kicks in. So basically, the 2 other containers are used to see what's going on behind the scenes. So let's invoke that one. And OK. So basically, we see what's going on. So we are booking the flight, we're booking the hotel, we are booking the car, and finally, we send an email to the users. Well, you can see, for example, that it took nearly 4 seconds for booking a flight, 2 seconds, 2.3 seconds for booking an hotel, and so on and so on. If we invoke that again, we'll have a different behavior. It's way faster. Why? Because the FN server is basically keeping those containers hot. So whenever we have new requests coming in for those functions, we are reusing the existing containers. Obviously, at some point in time, they will time out. Sorry? No, it's not transactional because we are going through the network. But that's a good point because we are going through the network, so it might fail. So that's why I have this tool, because none of my demo are failing, so I had to make sure that. So now, whenever I'm booking a car, it will just fail, right? So if we invoke that again, we should have a different path. So we're booking a flight, we're booking a hotel, and you see that we cannot book a car. So basically, what we are doing here, we are using the FNflow API to do some kind of transaction management. It's basically an implementation of the Saga patterns, where we basically roll back every single transaction to cancel basically everything. And you see that we have invoked the flight cancel, the hotel cancel, and so on and so on. And so you get the idea. So this is basically how the Flow API works. Now, all that code is on GitHub, so I encourage you to give it a look. So, ability to build complex application using serverless Java, yes. FNflow allows you to do function orchestration, and just that. FNflow is not a general-purpose framework that you can use to do anything. If we are talking about composition and orchestration of function, yes, FNflow is a good tool for doing that. So we can build using serverless Java a complex application. Now, let's talk about this latency question. So at the end of the day, given that we are using containers, we want to make sure that whenever we invoke a function, a Java function running in the containers, it starts fast. So there are multiple things that we can do. The first thing that we need to do is basically making sure that Java that runs in the containers is basically aware that it runs in the containers. So I will not go in details about that slide because it's very busy, but the takeaway of that slide is that if you look since Java 8, we are doing the investment into the Java platform to make sure that Java can work nicely when it runs in containers. And that's something important because, for example, Java has this ability to tune itself. So when you start a Java application, basically the JVM will look at some metrics like the available memory, like the number of CPU, and basically it will tune itself to make sure that it runs nicely using those metrics. If you are using an old version of Java, the JVM will not have access to those metrics. It will not have access to the metrics of the container. It will just see the metrics of the host. And obviously, they might be way different. So regardless of serverless Java, if you are using Java in containers, make sure that you are using a recent version of Java. So container awareness is something that we're dealing with at the Java platform layer. Now, we want to make sure that our serverless function starts fast. So there are multiple techniques that we can use. One of them is CDS, class data sharing. Anybody know CDS? No? So CDS is something that we have in the platform since Java 5, so it's not new. So the idea with CDS is basically whenever you start a Java application, your jar will be unpacked, all the class will be loaded into memory, but before they are turned into memory representation, the bytecode has to be scanned for security and so on. So basically a bunch of operations happen to your class, and obviously you have a bunch of classes. So this is quite expensive. The idea with CDS is basically we're doing all of that. Once this is done, the JVM will take a snapshot, so a snapshot of the in-memory representation of the classes. We dump that. So the next time your Java application is started, the JVM will just bring that in-memory dump directly. So we save a lot of time so that you don't have to go through all the operation like security check and so on. So CDS is something that we have seen in Java 5 for the class, so the runtime classes. And that will give you at least 25% in terms of startup time benefit. And it might be more than that. Since Java 10, we have application CDS. So same idea, but for the classes of your applications. So that's something that you should definitely use because it's free, it's in the platform, and it will improve the startup time of your Java code. And obviously, that's something that we are using on the serverless side. Now, next, if we want our serverless Java function to start fast, we should think about the fact that they're running into containers. Containers are made of layers. So that's something that we need to think about because at the end of the day, we want to make sure that all the layers that we have for our serverless function are as small as possible. If we look at a Java function, we basically have three types of layers. We have the operating system layer, we have the Java runtime layer, and we have the Java function layer that also includes the dependency of the function itself. Now, at the Java function layer, there's not much that we can do. We can just give you the advice of check your dependencies, basically. Check your transitive dependency and make sure that you're not bringing dependencies that are not needed, that are not used. Now, if we look at the Java runtime and at the operating system layer, there are a few things that we can do. First, we can use a lighter operating system, so a lighter Linux distribution, Alpine. Alpine is a highly optimized Linux distribution that only weighs, well, I think those days it's 4.2 megabytes. So it's a complete distro that we can use to run application. Now, there's an issue with that. Alpine rely on Muscle, so Muscle is basically the library that do the interface between C++ code and the operating system. And Java, by default, is using an alternative, which is libc. Now, we have the Project Portola, And the goal of Project Portola is to basically build OpenJDK on top of Muscles. So using Project Portola, we can use a Java virtual machine on top of Alpine. At the Java runtime layer, there are a few things that we can do. We should at least leverage the modularity that we have in the platform since Java 9. And we have this jailing tool that basically gives us the ability to customize the Java runtime so that it only has the modules that are needed for our code. So to give you some idea on the benefit that we can get using jailing. A whole Java 12 JDK, nearly 320 megabytes. That's a lot. Now, to run a function, you don't need to have a JDK. You only need a GRE. So that you can already switch to a GRE. Now, there is no Java 12 GRE. But to give you some idea of the weight of a GRE, I took the GRE of OpenJDK 11, 220 megabytes. So from switching from a JDK to a GRE, we already save 100 megabytes. Not only that, from a security standpoint, this is also a very good idea to run a function or any containers with just the bits that we're using. So clearly, to run a function, a Java function, we don't need Javassee. We only need Javassee at build time. So it would be dumb to have Javassee within the image of your function. Now, if you are using FN, you don't have to deal with that. That's something that the platform is handling for you. Now, we can improve that. If you are using jailing to basically build a Java runtime with just the modules that our function needs, we will still we will reduce the size. So 168 is basically all the modules. This would be very stupid to have a GRE with all the modules, because I think that technically it would be very difficult to write any kind of Java application that is using all the modules. So, but let's start from that, 168 megabytes. Now, we can remove some of the information from the GRE that are not needed, like header files, main page, and so on. From 168, we'll go down to 143. So we're saving 25 megabytes. We have two levels of compression. And if we compress to level 2, zip deflate, we are going from 143 to 83 megabytes. So we are saving another 60 megabytes. Obviously, at the end of the day, we want to have a GRE that only carries the modules that our function needs. That's what I'm doing here. And if we do that, we go down from 168 to 47 megabytes. We can remove information that are not needed, like header files and so on, 41 megabytes. And we can also compress that, 32 megabytes. So 32 megabytes will basically give us a Java runtime that includes all the modules and just the modules that are needed to run our serverless function. So by using jailing, we can save a lot of, well, we can greatly reduce the size of our function. And the idea is that we want the Docker image to be as small as possible, because whenever we start a function, it has to be loaded from the registry. Obviously, if you have a bunch of functions, you will have to load through the network all those functions. So we want to make sure that images are as small as possible. So let's have a look quickly on how we can do that in FN. So FN init. Now I'm going to switch to a different approach, and I'm going to use the init image. And let's call it this one, jailing. So I've created a Java function, and I will deploy that Java function. And I see it's jailing. It's again a very basic Java function. And Maven is kicking in, so that's one of the benefits of using Docker, is that basically we are leveraging the Docker caches, and this is painful at build time, but obviously at runtime we don't have to go through that. And I think I know why. It's because I'm pretty sure that there has been from the time I started the session to now, I'm pretty sure that there has been a new FDK release, so that's why I have to fetch my dependency again. Okay, so this is the Docker image of our function. Let's have a look at this Docker image. So anybody is using Dive? So Dive is a tool that you can use to basically explore a Docker image. So that's what I'm doing here. And if we look at this Java function, so those are the layers. The first one, 4.1 megabyte, is the operating system. The second layer is basically the function, so function.jar, and all its dependency. And if we look at the size, it's, well, 2.4 megabyte. And then we have these 33 megabyte layers, which is basically our custom GRE. So 33 megabyte for the GRE, 2.4 megabyte for the function and its dependency, and 4.1 megabyte for the operating system layer. That's basically all we need to run a Java function. So that's the whole Docker image. There's nothing more that we need. And the only thing that we need also is these 19 kilobyte layers. It's basically just a share object. That's something that is needed for FN. But that's not something that you have to manage. So basically, we have an image that weighs 40 megabyte, and it has everything: operating system, Java runtime, and the Java code to run the functions. Now, you saw that to do that, you only have to use this init image, JLink init, and the rest will be handled for you by the platform, by FN. So you don't need to understand how it works exactly behind the scenes. Now, we can go further than that. We can also use Graal VM to shrink more the final container image. So Graal is an open source polyglot high-performance virtual machine developed by Oracle Labs. It provides many capabilities, but the one that is interesting for us here is what they call native image. So basically, with native image, you are taking some Java code, and that Java code will be ahead of time compiled into a native executable that will run on a given target, Linux in this case. So let's see, and if you want to do that, again, in FN, it's pretty straightforward. So instead of using JLink init, you use native init. And well, this one might take a bit of time to build up. Yeah, I only have 2 minutes left, so maybe I won't have the time to go through. Well, it doesn't matter, because I already have one deployed, one function that has been natively compiled. I think it's in the Graal, yes, FNLS, FN Graal. So this is a Java function. And if we look at the Java function with Dive, well, 4.4, that's the operating system layer, and then we have this 16 megabyte layer, which is the Java runtime. Well, it's basically a Linux executable. And that Linux executable is basically our Java function that has been compiled to a native executable with the substrate VM embedded. Because we're starting from Java code, so for example, we're expecting to have memory management. That's something that is provided by a specific VM that is directly embedded within that executable. And we still have this 19 kilobyte share object that is needed by the platform. And you see that basically, if you are using Graal, we have a 21 megabyte Docker image that include everything to run our function. Now, obviously, there are some drawbacks, like, for example, in terms of GC, we don't have the GC that we have if we were using OpenJDK. So you need to basically do the balance between the two. So low latency, high performance, I think that it's fair to say that on the Java side, we have all the techniques that we need to basically achieve the latency that we're expecting for serverless function. Let's quickly talk about the rich Java JVM ecosystem. So Every 6 months, we have a new Java release. There are other languages that run on top of the JVM, like Kotlin, for example. We have Graal. So basically, we have a very rich ecosystem. So that's why we have added in FN this init image capability that basically allows us to easily cope with the rich JVM ecosystems. Like, for example, today we already support Java 13 on top of FN. So you saw me using init image for Graal, for jailing. That's also something that you can use to write support for your own language. So, for example, last month someone added support on FN for .NET using the init image capability. So that's something that you can use to basically extend the platform. Rich JVM ecosystem, I think it's fair to say that we can cope with that. So, serverless Java, does it have a feature? Absolutely. We have OpenJDK, we have Graal. And to be fair, today I've discussed using FN because that's the project that we are heavily contributing on. But there are other open source fast platforms that also rely on OpenJDK and Graal. So I think that the Java usage within the serverless space is just at the beginning. It's just at the beginning. So we are good and we're very confident about that. The call to action, give it a try. Everything is on GitHub. Install FN. The only thing that you need to have running on your machine is Docker. And if you like it, please give it a star. It's free and it's something that we highly appreciate. So with that, I'd like to thank you for your time. Yes. We have support for Lambda on top of FN, so you can run Lambda function on top of FN, or you can take FN and run it in any cloud, like Amazon Cloud. Yes, but not on top of Lambdas.
How does it compare?
What?
How does it compare with Lambda performance-wise?
There's no comparison. I mean, you can't really it really depends on the language and so on. So I mean, it would be unfair to do a comparison.